Greetings, Algebra Trig students. New chapter in our flipped classroom, chapter 7. It is called exponential functions, and I am going to do section 7.1 right now, and this should all be in the category of review, I hope. Okay, so section 7.1 is called the laws of exponents, and just to kind of grill them in your head, I'm going to give you some examples, but in the end you really just plain need to know these laws. Whoops, let's try to write this a little better. 7.1, again, laws of exponents. Okay, so first, anytime we have powers of the same base being multiplied, plain and simple, we just add the exponents. And just a quick example to remind you why that's the case. This is not magic. So say I have x squared times x cubed. What this really means, x squared is x times x, and what x cubed really means is x times x times x. And when we put that all back together again, we have 1, 2, 3, 4, 5 x's, and that's why a 5 goes there. So much easier to just realize you need to add exponents, especially if it said x to the 20th times x to the 30th, because you would not want to write all that out. Next law, x to the a divided by x to the b is equal to x to the a minus b. Whenever we have powers of the same base, and the same base is important, this can't be x to the a divided by y to the b. It needs to have the same base. All we do is subtract, and I bet a lot of you remember that, but just to grill it into your head, say I have x to the 5th divided by x to the 3rd. If you recall, that's the same as a fraction, x to the 5th divided by x to the 3rd, which is the same as x times x times x 5 times over x times x times x. That would be 3 times. And if you remember about dividing out when we're multiplying on the numerator and denominator, these guys just divide out to be the number 1. And so what we have left here is x squared. And in the end, it really is much easier to just take 5 minus 3 to get to that 2, especially if those were big numbers. Okay, next law. X to the a power raised to the b power. This is known as the power of a power. Is really just the same as x to the a times b. And a quick example to show you that would be something like this. X squared to the 3rd power really is the same as x squared times x squared times x squared. And if you go back to our rule up here, when we multiply powers of the same base, we just add our exponents. So 2 plus 2 plus 2 is 6, which is the same as taking 2 times 3, which is quicker. So 2 times 3 gets you to 6. Okay, a couple others. I'm going to go to a different board to write 2 more. Okay, the next one is when we take the power, have a power of a product. It is a fact that x times y in parentheses to the a power is the same as x to the a, y to the a, and that comes in handy sometimes. So I guess just to remind you of this, if we had something like 2 times 3 to the 4th power, if you recall, then that really would mean 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3. And really, it's a 2 getting multiplied 4 times a 3 getting multiplied by itself 4 times. So a lot of times it's easier to, and sometimes we get it served up in one direction and we take it the other way because it's easier to solve. Now in this particular case, I'd say more than likely, hopefully you'd realize that taking 6, 2 times 3 is 6 to the 4th, will be easier to get to that answer. Okay, and then along the same lines, when we have a quotient, x over y, raised to a power, we can rewrite that as x to the a over y to the a. And once again, this comes in kind of handy at times. So just as an example of that, if we had something like x over y cubed, if you remember, what that really means is x over y times x over y times x over y. And when you look at it like that, you can pretty clearly see that it's the same as x cubed over y cubed. So, 5 laws come in handy. I'm going to just do a few examples to apply them. Example 1. And once again, this should be review for a bunch of you, I'm thinking you're just saying, oh, I know all this. This won't be very difficult at all. So say I have a cubed b squared times 3 a squared b. I'll put this in parentheses just for fun. Now, don't let parentheses, this is a common error I see where you think parentheses mean you're doing some kind of foiling thing. If you notice, even though I put parentheses around this and I put parentheses around this, in the end, everything here is just getting multiplied because there's no plus or minus signs. So I'm just going to rewrite the order of this. I'm going to write 3a cubed, and I'm going to join it up with a squared times b squared times b. So the 3 just comes along for the ride. A cubed times a squared is a to the 5th. And b squared times b, remember, anything that doesn't have a power really has a power of 1 above it, so that would be 2 plus 1, which is 3. Okay, another example. Simplify x to the 4th, y to the 5th, divided by x cubed, y squared. And just to remind you, another way this could be written is x to the 4th, y to the 5th, all over x cubed, y squared. And it would be a pain to write out x times x times x times x and y times itself 5 times. So this is where just remembering your law that when we divide powers with the same base, we just subtract our exponents. And then likewise, this y is a different base, but it has a y up on the numerator, so y to the 5 minus 2. So we get x to the 4 minus 3, which is 1, y to the 5 minus 2, which is 3. And it's okay to leave the 1, but normally we wouldn't write that. So that would be xy cubed. Okay, a couple more examples. Simplify c cubed d squared squared. Now, there are a couple different ways to think about this. One way would be to just realize that this is shorthand for c cubed d squared times c cubed d squared. And realize that what we really have is c cubed times c cubed and d squared times d squared, which ultimately we're adding our exponents, so we get c to the 6th, d to the 4th when we add those. But using our power of a power law, we can say, well, really what this is c cubed squared times d squared squared. So if this product is getting raised to that 2, I can break out each factor and raise it to the 2. And now I'm actually going to use my power of a power. So c to the 3, c cubed squared is just c to the 3 times 2, which is 6, times d to the 2 times 2, which is 4. Easy! Maybe you like it better already than sequences and series. Okay, one more example and then a couple comments. Say you are asked to simplify a to the 4th times 3b to the 7th all over a times 3b squared. Now, there are many different ways to do problems like this, but I'm going to attack it from what I think is the easiest way. So if I have a 3 times a b in parentheses to the 7th, it's the same as 3 to the 7th b to the 7th. And I'm going to do the same thing down here. So on the bottom I have this a, but then I have this 3b squared. So that's the same as 3 squared times b squared. Now to finish the job, I remember that this a really has a 1 above it. So I have a to the 4 minus 1 times 3 to the 7 minus 2 times b to the 7 minus 2. I guess they both have 7 minus 2. So we normally would write the constant, in this case it's a coefficient in front, so this would be 3 to the 5th, a to the 3rd, b to the 5th, and if you use your calc or you calculate out in your head, 3 to the 5th is 243. So 243a cubed b to the 5th. Okay, comment on just a couple places where sometimes there's trouble. So note, something like 3a to the 4th is not the same as 3a in parentheses to the 4th. Because this is just plain old 3a to the 4th however you look at it. And if you remember, this is 3 to the 4th a to the 4th. So in the end, this is 3 to the 4th, which I believe is 1296, a to the 4th. Not the same. Yes, the a to the 4ths are the same, but the coefficient is not. So be careful with something like that. Just another trouble area, I would say, is yes, it is a fact that negative a is equal to negative 1 times a. Oftentimes we don't write the 1. But it is not true that negative a to the 4th is equal to negative a in parentheses to the 4th. So be careful with that. And let me just go through this. I mean, this really is just negative a to the 4th. But this, if you think about there being a 1 in here, is really negative 1 to the 4th times a to the 4th. And when we take a negative 1 times itself 4 times, that becomes a positive 1. So this is 1a to the 4th, usually just written as a to the 4th, which hopefully you can clearly see does not equal that, so we need to be careful. So just the last thing I would think about is the whole thing that happens with negatives. So negative 1 to the first power is negative 1. Negative 1 squared is 1. Negative 1 cubed is negative 1. You see the pattern. You've seen it before. Negative 1 to the 4th is positive 1 dot dot dot. So just remember, when we are raising things to even powers, we're going to be getting positive numbers. And that is all for section 7.1.